Hello everyone, welcome back to the channel. If you are new to the channel, please subscribe the channel and please like the videos, and if you find it useful, please share with your network. So as I promised that today we are going to learn about the data types in Java. We'll be covering all the 8 primitive data types that we have in Java. So before that, we'll just have a quick recap that what we have covered till now. So we started with the execution process in Java. We learned the difference between the compiler and interpreter. We discussed about what are variables, what are the use of variables, how do we declare and initialize a variable, what is the means how do we reinitialize a variable, what is the difference between literal or expression values, and also we have discovered what are comments and what are the uses of comments and what are the different kinds of comments in Java. So as I said that yesterday, that you don't have to worry about the int in the variable. This int you don't have to worry, as I have mentioned yesterday, but now today we are going to learn about what is this int, what are the other ways or what are the other types that I can give to a variable. So let's get started with this. So as I said that we are going to emphasize today on primitive data types, but before moving to this, I'll just let you know that there are two types of data types. There are two kinds of data types. The first one is primitive data type. The next is, or I can say the second one is non-primitive data types. So now you may ask me that what is the difference between primitive and non-primitive data types. So primitive data types are the data types that are already defined, which means already defined or predefined means that it has been developed or created by the inventor of the Java. So we don't have to create this kind of data type, they are already defined by them. Non-primitive data types are user defined, that which means that we user are going to define this kind of data types. And one exception in non-primitive data type is string, because string is also a non-primitive, or I can say that string is the only non-primitive data type that is predefined in Java. But other non-primitive data types like classes, arrays, object references are user defined. So we as a user, we need to define this kind of data type. So as I have mentioned that today we are not going to focus on non-primitive data type, so don't worry about the non-primitive section. Today we are going to emphasize on primitive data types. So I hope till now it's clear to everyone, and we'll proceed further with the primitive data types. So as I have said that there are total 8 primitive data types. So they are byte, short, int, long, float, double, char and boolean. So what we can do is I'll just bifurcate it into 4 parts. The first part I'll make it as integer. See, this bifurcation is done by me. It is not any official bifurcation. It is just made for make the topic easy to understand. So I'll bifurcate first 4 in the integer. I'll just put this starting 4 data type, byte, short, int and long, into the integer. So let's take them over here. Byte, short, int and long. These are the 4 data types that I have put into the integer kind, and another kind I'll declare as floating point. So in the floating point I'll put float and double, and then the third one is char, or I can say that I am bifurcating it into character, and inside the character I am putting char, and the fourth bifurcation is boolean, in which I am putting the boolean. I know it might not be clear at this instance, but as soon as we proceed with each and every data type, it will be getting clear and clear. So first, as I said that we'll focus on integer one. We'll see how these 4 types or what kind of data these 4 data types hold, and then we'll see what are the differences between them. That's why they have given 4 name, or that's why there are 4 different kinds. So we'll see the difference between them as well, how can we use, and what is the suggestions given by the developers. So let's proceed with the integer kind, in which I have bifurcated byte, short, int and long. Okay, so in integer, as I have mentioned, that I have put the byte, short, int and long. I hope this is clear to everyone. So now first, the reason why I have put this 4 into the same kind. Your question might be this, that why I have put this 4 into integer and why other into other kind like floating point and char and boolean. So what is the difference between these 4? Why they are not in the same kind? So I'll explain you the difference, that how these 4 are similar and how they are dissimilar as well. So first of all, I'll let you know that in integer I have, or we can store a whole number or a fixed number, as I have mentioned over here. So now what is a whole number? The number that starts from zeros like this, or a fixed number. So why I am saying that it is a fixed number? Because let's say 0, 1, 2, -1, 10, -20, -100, all these are numbers, but they are fixed. They don't have any precision, or they don't have any approx values. Like if I say 1.09, so we might assume this as 1.1 as well, or this is not precise, this can be 1.09945 or something like that. So they are not fixed, they are decimals, so they are not fixed numbers. So these numbers like 1, 2, 45, 400, 600, they are a fixed number. So in integer we hold fixed numbers. So in integer, what types do we have? Byte, short, int and long. So these 4 kinds can store whole or fixed numbers like 45, 65, -20 and the numbers like this. I hope this is clear. Now your question might be that what is the difference between them, how they are different, and why. See, this is the basic similarities between them, that they hold a data of the same type. But now we'll see the difference between them. Now as you can see that byte is having a size. See, the major difference between byte, short, int and long is of size. Size is the only difference we can say for now. So byte, the size for byte is 1 byte, that is 8 bits, and the range, you can guess it, like for 1 byte it starts from -2 power 7 to positive 2 power 7 minus 1. So this is the size of byte. Then for the short it is 2 byte, so it will be double, like 2 power 15 to positive 2 power 15 minus 1. I hope till now it's clear to all. Then int takes 4 byte, that is -2 power 31 to positive 2 power 31 minus 1, and for long it takes 8 bytes, and long can store values from the range -2 power 63 to positive 2 power 63 minus 1. Okay, the 1 is over here. Okay, so I hope this is clear to everyone, that the longest, or I can say that the largest among this is long and the smallest among this is byte. Now we'll see how do we declare a variable. Yesterday we have seen that we can declare a variable of type, or we have declared a variable of type int, like int a is equals to some values like 100. So this is the way we declare a variable. Now I can also declare a variable of type byte. It's up to me that which type I choose. I can use byte b is equals to 100, short b is equals to 100, or short s is equals to 100, long L is equals to 100. It's up to me that which data type I choose. I can choose long, I can choose short, I can choose byte, I can choose int. It up to me. And there are 4 other primitive data types as well. We'll discuss about them after a while, but first we need to get a clear idea about how integers get their memory. So we'll just move down to the Eclipse and we'll try to declare some variables. So yesterday we saw that how to declare a variable. We need to give a type to the variable, we need to give the name of the variable, and then we can give the value in the form of literal or expression values. Now we'll see, now we'll declare all the 4 primitive data type that we have discussed till now. So let me delete this. I can say that the first one was byte b is equals to 100. I can declare a variable b, I can store 100 in it, and I can declare the size, or I can declare the type of b as byte. So now b will have the size of in the memory. Now what happens behind the scene? Let's discuss this. As soon as I declare a byte variable, the compiler will say, hey, okay, it's a byte, you need to allocate 1 byte of space in the memory. So now this 1 byte of space is been allocated in the memory, and b is pointing to this particular address. So let's say the address is 20 or 256, let's say, or 2560. This is the address. So a b is pointing to this address, and this address is of size 1 bit, oh sorry, 1 byte. Yes. So now this address can hold value that can be in the range of 1 byte. So that is from minus 128 to positive 127. It can store the value of this range. So now I am storing, now b is pointing to this memory address, that is 2560. Now I am storing 100 in it. There's no issue because it is inside its range. And as soon as I go beyond its range, that's obvious that we'll get an error. Okay, so we'll discuss that later, but for now I hope this is clear that how memory allocation takes place. If I give byte, the memory of 1 byte will get allocated. If I give short, then memory of 2 byte will get allocated. So it's up to you that which data type you choose, but it will be giving the memory size of their particular range. So now let's proceed with short. I'll declare another variable as short. Short s is equals to, I can give any value like 189. Int I is equals to 45. Long L is equals to 567. Now one thing you need to make sure that you can declare a long variable with a tailing L. What do I mean by tailing L? That I can give the L or small letter L at the end of the value, which will tell the compiler that this is a kind of long. Now your question might be that, hey, I have given long over here, then why do I need to give this L? We'll explain this, or we can we'll be going to this concept when we move to operators, but for now we can say that any values like this is considered as int for now. So this 567 will be considered as int, and if to make the compiler sure that it is a kind of long, I can give the tailing L. Now your question might be that, hey, I am not giving any tailing L, then too it works fine. Let me print this. Let me give b, this out, s, this out, I, this out, L. So this is how I can print the values of all these variables. Now if I am printing this, let me run the program and I get the desired output. Now the output is correct. Now your question might be, then why do I need a tailing L? Correct? Just yeah, why do I need a tailing L? So the long is largest among them, so I can store any value. Even I can store b's value, I can store s value, I can store i's value as well. But as soon as this value that I give inside the L gets beyond the int range, okay, int range is minus 2 power 31 to positive 2 power 31 minus 1. So which means I cannot store a 10-digit number in int. like this. As soon as I give this, it says that the literal and this value of type int is out of range, which means this value is getting beyond the int's range. So int cannot hold this. So which says us that hey, do not store this long values to it. So I can just eliminate one digit and like this. Now this works fine because this is inside the int range. Int can store this value because it is inside the int range. And one more thing, like also see, for the byte the size ranges from minus 128 to positive 127. So as soon as I give 128 over here, we'll get an error again. The type mismatch cannot convert from int to byte. But again, you don't have to worry about this. As I said that when we deal with operators, we'll see that why it is setting int over here. So don't worry about this. So I can store up till the range of 127. Okay, someone is asking that how we get to know the data will have this much of memory. See, that's the reason why I am giving the data type over here. If it is of type byte, it will be having 1 byte of space. If I am giving short, it will be having 2 byte of space. If I am giving long, it will have 8 bytes of space. So that's the main reason why we are using the data types. So as soon as I go beyond the int's range, we get an error when we store the value in the int. So let's again check. Yes, so I get an error that the literal this value of type int is out of range. Okay, so now what I can do is, your answer will be okay, you can store this value in long. See, now again in long we are getting the error. Let's see what it is. The literal 4 5 and this value of type int is out of range. So which means that this is considering this as a int. So for making sure that the compiler interprets it, or the compiler looks it as a long value, so I can give the tailing L or the small letter L like this. Now it works fine. This L says that, hey compiler, this is a kind of long value, so you can check that whether it is inside the range of long or not. You don't have to check for the int. So one thing you need to note is, like, as soon as the value goes beyond the int range, you need to give the tailing L. Then only you can store the value inside the long. Okay. So it depends upon the system. Yes. So I hope this is clear to all till now. Why do we need this data types? To allocate some memory. And what is the difference between them? Is the size. Byte is the shortest among them and long is the largest among them. So I can give bytes value to short as well, and we'll see this when we move to typecasting. Don't worry about this. So yes, this works fine. So we don't have any errors now. So as soon as the value goes beyond the int range, I can give the tailing L so that it get read as long values. Okay, so now one more thing that we can learn is, if I declare a variable int j is 10000 this value, so this value is a 1 2 3 4 5 6 7 8 digit value. So now this digit might be very confusing, or like might be difficult for human eye to get it read by the user. So what we can do is, we can separate the zeros or we can separate the value based on the underscores. So it's up to us. See, these underscores are just making the value readable. It is not affecting anyhow the value. So value will be behind the scenes, will be read as by the compiler. The compiler will read it as 1000000 only, but this is just for the ease of us. So we can use underscores between the numbers so that we can get a better visualization of the value. It's up to us whether we use it or not, but behind the scene this value only gets allocated to it. So we can use underscores. Now the next thing is we can store, see, this kind of value were fixed, but I can also give other fixed values, like I can also give values like hexadecimal form, the binary forms, the octal form, or in even the ASCII forms of the values. So let's say I am declaring a variable int k or int z is equals to let's take hexadecimal form 0. Yes, now this is a hexadecimal form, so if I print it, sys out z, see, it will give us 65 because this 0x41 is the hexadecimal representation for the value 65. So in the hexadecimal, this 45 gives us the answer as, or gives us the output as 65. So if I give it as 42, what will get? See, we get 66. So we don't have to worry that how hexadecimals stores the value, but we just need to get aware that we can store hexadecimal forms in the variables like this as well. So I can use byte as well. See, this characteristic of all the integers are same. That's the reason why I have put them all together, like the byte, short, int and long. You can use any of this type with byte, short, int, long. You just need to take care of the size that doesn't exceeds the range of them. So I hope this is clear that we can store the hexadecimal forms as well. Yes, then I can store, let's say, int y is equals to, I can store binary forms as well. If I say 0b and if I give any binaries, okay, so this is the binary form. If I just try to print this, system.out.println y, now it gives us the value as 9 because binaries starts from 1 2 3 sorry 1 2 4 and 8. So the 8 flag is set, and for the 1 the flag is set, so 8 plus 1, it is 9. Okay, now again you don't have to worry about like how the binary representation is, you can learn it later, but for now this is just for making you guys aware that we can store binaries as well. Now the last one is I can store octal format as well. See, 100101. So if I store values like this, and if I say x, it will give us 65. So this 0101 in octal format is of gives us the value or represents the value 65. So don't get misinterpreted that if you are having values like 09 or 0101, so it will be having the answer as, it will be equal to 101. No, it will be get read as octal value. So just be aware about this, and I hope this is clear to all. Yes, so why you have written OB? The OB, see, I need to tell the compiler that this is a kind of binary form. So after OB, anything you write must be of the type binary only, and OX stands for hexadecimal, and this stands for 0 stands for octal. So if I give any value, like for this, if I give it as 01, now let's see what value do we get. Okay, in octal it is the same. If I give 12, see, if I give 12, I get the value, I get the output as 10. So don't think like 012 is equals to 12 only, because it is getting read as octal. So in octal, what representation or what it is representing will get that particular value. Okay, now if I am saying that int k is equals to, I can give any character. So if I want to give any character like capital letter A, so this will fetch the ASCII value for this A. So in ASCII, the value for capital letter A is, I guess, 65. So let's print this one as well. If I say system.out.println k, see, it is 65. If I give small letter A, it is something around 97 or 96. Yes, it is 97. So for this, if I give any character, it will fetch the ASCII value of it and it will give us that output. So what happens behind the scene over here, we'll discuss that as well. Okay, now what happens over here is, as soon as I say int, okay, you need to store a 4-byte, or you need to give a 4-byte allocation to k. So k is pointing to this memory location. This memory location can store the value within the range of -2 power 31 to +2 power 31 minus 1. So this is the range because it is of 4-byte. Now k, I have said that okay, you need to store this value into k. Now I have given k as int, so characters cannot get assigned to k directly. So what will happen, it will fetch the value for this character behind the scene. So what is the ASCII value for A? Okay, it is 97. So let's allocate this to 97. So this 97 will go over here, not the letter A. So this 97 gets stored in the memory, and whenever again at the line number 23, if I try to fetch the value of k, it will point to this particular memory location, and what this memory location have, it is 97. So it prints 97, and the same goes for other format as well. So if I am having hexadecimal, so what will happen, okay, it is a kind of byte, give it a memory allocation with 1 byte range. B is Z over here, Z is there, so Z is pointing to this particular memory location. The size or the range of this can be of 1 or 1 byte. Okay, so the range for this is -2 power 7 to +2 power 7 minus 1, that is from 127 to 120, sorry, 120 minus 128 to 127. So I can store any value within this range. Now what happens behind the scene, okay, I am assigning 0x42. So this is not a integer format. I am having numbers like this 0x, so I cannot store this over here directly. So what it will say that, hey, it is having 0x as the prefix, which means it is a kind of hexadecimal form. So I need to say that 4 into 16 power 1 plus 4 into 16 power 0, that is, okay, sorry, it is 1 over here, yes. So 1 into 16 power 0, which means 64 plus 1, that is equals to 65. I need to store this 65 over here. So when at the line number 20, whenever, means as soon as I fetch the Z, it will point to this particular memory location and it will read this value. Okay, 65 is there, I need to print this value to the console. So we get 65 in the console. I hope this is clear to everyone, that how memory gets allocated to a particular variable and how we initialize, what kind of format it supports, and like the hexadecimal format, binary format, octal format, ASCII, and also we can use the underscores for increasing the readability. Yes, so Aditya Ghosh, your question is, the value of capital letter A and small letter a are fixed. Yes, so in the ASCII, whenever you can fetch the ASCII chat on the Google and you can check the values for this particular character. You can use any character for B as well. So for capital letter B it will be 66, for small letter B it will be 98. So they are fixed value in the ASCII chart. so it retrieves that in that format. So yes, so this is clear to everyone. Now let's proceed to our next kind of variables. So we have discussed about all the 4 variables that we have bifurcated inside the byte, short, int, long, inside the integer format. So in the integer I have byte, short, int and long, and we saw the similarity between them and also the difference between their sizes. And one more thing, that it is suggested to always go with int. It is suggested to always go with int because means it is recommended by the developer, and we'll see that why int is recommended and why doubles as well. So we'll see that later, but for now I hope this is clear to everyone that how do we can use this values, and whenever the value range exceeds after the or goes beyond the int, we can use the long and we can give the trailing L. So one thing you need to note, that always stick to int, and if the value goes beyond int then you can choose the long, and byte and short you should try to avoid, and you should only use whenever memory consumption is you need to take care of the memory allocation or the memory space. So you should always stick to int. So now let's move to okay yes so now let's move to floating point. So in floating point, till now we have discovered for integers. So in integers I have given byte, short, int and long. So this holds only the fixed values like 1, 200, 200, minus 400, the values like this. But now we'll deal with floating point. So this floating point means in this floating point I can store any decimal values, because there might be situation there where we need to store decimal values, like in the calculation stuff. For the banking application we need some decimal values, so there is a need of storing this decimal values into some variable. So what data type should I use over there? So I can say that we can use floating point data type, and in floating point we have given float and double. So this float and double stores values which can have decimals, and also it can store normal values as well. But what happens behind this, in this 3 will get read as 3.0, but then too it's having the same value. So floating point are always used to store the decimal values, or I can say that real number. So in floating point we have float and double. So float and double, now again the difference between them. So float is of size 4 bytes, that is 32 bits, and double is of size 64 bits, that is 8 byte. Now you can see the difference in the size range. Okay, just note this, because when we move to the typecasting we'll need this information. So now for the float is of type size 4 bytes. So for 4 bytes it is having the size of minus 3.4 into 10 to the power 38 to positive 3.4 into 10 to the power 38, correct? So this power is way bigger than int range, because for int I have got only, let's check that one as well. For int I have got only the size of minus 2 power 31 to positive 2 power 31 minus 1, though int is also getting the memory storage of 4 byte. Okay, now your question may be, hey, how can this floats can store this long value in the 4 byte only? Now the reason for this, in the memory they will consume 4 bytes, but both of them are having their particular range. For int it is a fixed number, so its range is fixed, that is this to positive 2 power 31 minus 1. So this is the int range, but for float, though it contains the decimal points, the size of it is increased to positive 3.4 into 10 to the power 38. Okay, in the memory it will be consuming the same space, but the range for them varies. So just keep that in mind. That's the reason why floating point and integers are kept separated from them each other. And also we can understand the difference that in floating point we can store the decimal values, while in the integer we cannot store the decimal values. And for float the size is 4 byte, but it is greater than the int. And for double we can see that it is of 8 byte, but then too it is again greater than the long, because this 1.7 E308 means that minus 1.7 into 10 to the power 308, and this is again a very long value or very large value. So this is the greatest among all the data type that we have discovered till now. So we are going to use data type which we need. If I want a fixed number, I can use the int. If the number is bigger but it is a fixed, then I can use the long. But if it contains a decimal, then I have two options, float and double. Now your question may be that which one we should choose. So again, it is recommended to always go with the double, because for the float the precision is not that much, and we'll see that when we go to the IDE. So for now, as I said, that double is the one that we are going to stick with. And yes, we'll discuss this tailing letters. So let's move to Eclipse and let's practice this. Okay, I'll comment this all. Yes, now I've commented this. I can declare variables. Okay, so I'll declare a variable float f is equals to 4.76 or 67. Now we are getting an error. It will say that type mismatch cannot convert from double to float. Now again, the reason for this we'll be discussing when we move to operator, but for now we can say that any decimal values will be read as double. So don't worry about this, we'll discuss this. So now your question might be that how can I store this 4.67 inside the float type, because it is for sure that it is inside the range of float. So how can I do that? So I can give tailing f or capital letter F, it's up to us which one we choose, but we need to give the tailing f so that we tell the compiler, hey compiler, this value is not of type double, it is of type float. So you store it in the, you can store it in the float variable. For double, you can say double D is equals to 56.98. Now for double, there is no need of providing any tailing letters, but it's up to us. We can give tailing D or capital D, it's up to us, but it is not needed because always the decimal values are interpreted as double only. So no need of tailing D, it's up to us, but no one uses that tailing D for the double values. Now if I try to print this, yes, so we get the value as for 4.67, and if I give D, we get 56.98. Now let's see if I increase this, okay, and if I select the same value for double, yes, so now if I print this, let's print both of them, system.out.println f. Now if I print this, can you see the precision? It is not that precise. Someone is saying that generally float is preferred for amounts. So can you see that when in the banking each and every decimal gets counted, So I cannot use float because this much of the decimal, there is a approximation for these values. We cannot get it approximated to this. So float is only precise for 4 to 5 values, while double is more precise than float. That's the reason why we need double. So that's the reason why I have said that always stick to double, because double is more precise than float. Only use float when you need memory saving, and nowadays memory saving is not the bigger aspect or not the big issue, because memory nowadays is cheap. We need to improve our performance. So I'll prefer that always use double, and double is more precise than float, that we have already proven that. So tailing f is needed whenever I declare a variable as float, and tailing d is not mandatory. It's up to us whether we use it or not. So let's move to our next data type. Yes, so our next data type is character. So in the character, what we have, you can just get an idea that character means a character, means A, B, C, D, something like that. So in character, I have given only one data type, that is char. So in char, I can store characters like A, B, C, D, but just mark this point as important because it is stating that character stores single variable or single character, which means I cannot use AB together. These are not character. Okay, they are not a character. Only character means 1, 0, @ B, Z, capital H, 9. These are characters. Percentage. These are characters, but these are not characters. Character in char, we can store only a single character. Let it be 0, let it be @, let it be any special character. Though they are special, but they are character. So I can store them in the char type. So I can store any character, but only a single character. So, and one more thing, that we need to give the character inside the single quotes, because this single quotes tells the compiler that okay, the value that I am providing is a kind of character. So anything inside the char means inside this single quotes will be read as character or char. So I can give A, I can give 0, I can give @, but I need to give them in the single quotes like this. Now let's try this in the Eclipse. And one more thing, that the size of this size of character is 2 bytes, which means it is smaller than int, obviously, but the range for this, again note this point, when we will move to the typecasting, this point will help us to understand. So for character, the size range starts from 0 to 2 power 16 minus 1. So it doesn't start with negative, because no character lies in the negative range. Always the character range starts from 0 to positive 2 power 16 minus 1, and we'll see, and default value we'll learn together when we discuss all the 8 primitive data types. So let's move to Eclipse and let's practice this one as well. Okay, so if I say char C is equals to, I can give any character like this A. If I do system.out.println C, now this is printing the A because I have given A inside the character. While I was doing the same stuff with the int, what I was getting the ASCII value, because this A cannot get stored in the int format. Int format stores only the integer, only the fixed number. So it just converts this character to the int format, and then it gets stored or it get allocated in the memory. That is, we were getting 97. Now I am storing this character in its specific type, that is char. So I can store this A inside it. I can store ampersand, I can store braces like this, parenthesis. It's up to me. I can store numbers, but I need to provide it in the single quotes. Now one more thing, as I have discussed, that I cannot store two characters at the same time like this, it will give us an error, invalid character constant. Then too, if I try to run it, we'll get an error that unsolved compilation problem, invalid character constant. So don't try to do this, because char can store only a single character. But when we were dealing with int, we were able to store, or we were able to give the value of character a to int values, because it was doing the conversion from the ASCII values. The ASCII value of a was 97. So the same I can do over here. If I don't give values in the quotes, if I say 97, then what will happen? Let's see. See, we get the value as a. Now what happens over here is, as soon as I say, okay, you need to store a char, so 2 bytes gets allocated in the memory. 2 bytes gets allocated in the memory. Then after this, C is pointing to this particular memory location. I need to store 97 to it. Is 97 compatible with char? You will say no, I cannot store char, or I cannot store any numbers to it directly. So what will happen? It will go into the ASCII values. It will fetch the ASCII value for 97, and what is the ASCII value for 97? It is a. So I can store, it will store a over here. Now at this line number 36, when I am invoking the C, when I am calling the C, it points to this memory location, retrieves this value, and the value is a, so it prints a in the console. That's the reason why a comes out to be in the console. So I hope this is clear to everyone. I can also give the ASCII value like this. Now let's see whether we can give hexadecimal values or not. So 0x41, it was standing for 65. Now again, what happens is 65, see, we have already discussed that 0x41 means 65 in int. Now again the same process takes place. 2 bytes allocated, C points to this memory location. I need to store this. This cannot be interpreted directly, I need to convert it to a number. Can I store 65 to this position? You will say no, because it is only, I can store only characters. So it will fetch the value for this 65 in the ASCII chart. So in the ASCII we have 65, we have capital letter A for value 65. So that's the reason why this A gets stored over here. So now over here, if I am fetching this, if I am invoking this C, it points to this memory location and gives us the value as A. So I can also give binaries. We'll see this one as well. So I can give binaries, I can give the octal format as well. So it's up to us which format we choose. So you just need to be aware that I can give all the kinds of values to it. So if I say 0b 1010, now okay, for 65, what is the value for 65 will be, we know that in the ASCII for 65 it will be 64 plus 1. So 64, 32, 16, 8, 4, 2 and 1. So I can say that I need to give 1 0 0 0 0 0 1. So if I give this value over here, now let's see what output do we get. See, we get capital letter A, because this binary representation for this particular number is means 65, and 65 in the ASCII means capital letter A. So it stores the capital letter A for this, where for the position where C is pointing. So in the memory, wherever C is pointing, it stores capital letter A at that position. So if I say this as 0 and the next bit, if I set the next bit over here as 1, then it will be 66. So it will give us B. If I make this as 0 and make this as 1, so it will be 68, I guess. So we'll get D. I hope this is clear to everyone that we can store binary forms as well. Now let's see the hexadecimal forms as well. So 0101 stands for 65 again. So 65 in the ASCII gives the result for capital letter A. 6_5. Can I do this? Let's see. Because whenever I use underscore like this between two numbers, it is just for human eye, it is just for us to get it easily understandable or to read it easily, but behind the scene it will be read as 65 only. So 65 again, it just represents the value or represents the capital letter A in the ASCII value. So I can store this in the char. What if we put 97 in single quotes? Okay, see, if I put 97 in single quotes, what will happen? In single quotes, I can have a single character like this. If I print 9, it will work, we'll get 9. Yes, we get 9 as the output. If I use 7, we'll get 7 as the output. But if I give 9 7, then what will happen? It will give us an error because it is not a proper or it is not a character format. So it will give us an error that invalid character constant, because inside the single quotes means whenever I am using the single quotes, which means I am declaring a or I am assigning a character, and as I said that char C or char can hold only a single character, so I cannot store two characters together. So it's up to me which one I choose. I can store 9 or I can store 7, but I can choose any one of them. I cannot store both of them together. If I remove the quotes and I say 97, then let's see what happens, because 97 in the ASCII chart stands for small letter a, so it will give us the small letter a. Yes, so hope this is clear to everyone. Now let's proceed with the last data type, that is Boolean. So Boolean, in Boolean what happens, we can store only true or false values. In Boolean we can store only true or false values. So if I want a variable which I want to use it for only storing two values, then no need of using any string or any char like that. I can use Boolean, and Boolean can store only true or false values. So if I want to store a false or if I want to store a true, which variable or which type I can choose? I can choose a Boolean type. So in Boolean I can choose true or false value, but not any other value, like not 0, not 1, not 2, not 10, not -1, not character like this, nothing like that, and not 3.14, not 4.56, nothing like that. This won't work with the Boolean. Only true or false, only true or false work with the Boolean. Now again, there are some articles, if you see or if you search for that what is the size of Boolean, it has been like in some article it is said that bit size of Boolean is JVM specific. So it is not fixed like that, it is JVM specific, but yes, it is mostly 1 bit. So you usually see that the Boolean size is 1 bit, but actually it is JVM specific, but mostly we can say that it is 1 bit. I hope this is clear to everyone. And the default value for Boolean is false. So if I do not assign any value to Boolean, then it gets a default value as false, and we'll see this. But before this, we'll try to store true and false in the Boolean. Okay, so now if I try to declare a variable, I need to say that Boolean, I can store B, I can store true or false, it's up to me. If I say system.out.println B, the output will be true. If I store false, the output will be false. But if I try to give any values like 9, we'll get an error, type mismatch, that cannot convert from into Boolean. If I give 0, again cannot convert from into Boolean. I cannot give 1, I cannot give characters like this, I cannot give strings like this. Now again, string is not cleared or not completed till now, so don't worry about strings. What are strings we'll discover later. And I cannot give any, not even the binary format. So Boolean only works with true and false values. So I can store either true or false, but I cannot store anything else other than true or false. So it's up to me which one I store over here, and will get that printed over here. Now I cannot show you the default value over here directly, because for that we need to learn about the global variable, that is the variable that we declare at the class level. So we'll discover that later, but for now we need to note that the default value for Boolean is false. So if I do not assign any value to Boolean, it will be false by default. The default value for this character is Unicode 0. So it is in this format, \u and 0000, and the default value for floating point is obviously 0.0. So for float it is 0.0f, for double it is 0.0d. D is again not necessary. And for integer, for all the integer like byte, short, int and long, it is 0. So I hope all the 8 primitive data types are clear to everyone, and if you have any doubts you can ask me. Okay, so Boolean b is equals to 0, what happens then? Now if I give Boolean b is equals to 0, then what will happen? It will again give us an error, because 0 it is interpreting, or it is reading it as int values. It is reading it as int value, so it will give us an error, that type mismatch, that I cannot convert from int to Boolean. So that's the reason why I cannot store any other value other than true or false. So do you have any other doubts? Okay, so tomorrow we'll deal with new topics, and we'll go with new extra topics, but for now you need to practice about the data types, get the discover the stores, means the size of each data type, like what is the size of byte, short, which one of them is the largest, which one of them is shortest. Just keep that in mind. And as I said that we are always going to stick with int and double. Whenever fixed number we are going to store, we will be using int. Whenever I want to use decimals, I'll use double. And if the value exceeds the int range but it is of type fixed, then I'll use long. And for storing true or false I can use Boolean, and for storing a particular character I can use char. So I hope this is clear to everyone till now. And non-primitive data types, you don't have to worry about that for now. We'll see that later, and tomorrow we'll start with typecasting, that what is typecasting. So if you have any doubts you can just put it in the comment section, I'll definitely answer to it. So see you all tomorrow at the same time, that is 7:30 p.m. and I'm closing the stream.